In this video, we're going to take a look at prime numbers and prime factorization. So the first thing we've got to understand is what is the difference between a prime and a composite number. A prime number is divided evenly by only one and itself. So some example of prime numbers would be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on. Okay, they're divided evenly. Like for example, 2 is only divided by 1 and 2. A composite number is divided evenly by more than one itself. So for example, 4 is divisible by 2, 1, 2, and 4. 6 would be 1, 2, 3, and 6. 9 would be 1, 3, and 9. Okay. 25 would be divisible by 5. 60 would be divisible by a lot of numbers. The two numbers that get left out of this system would be 1 and 0. Because in some ways they act like prime, sometimes like composite, especially when we get into advanced number theory. So for right now, we just say that they fall underneath neither category. So when we look to prime factorization, remember, is the DNA of a number. So it's the unique listing of a number as the product of the prime factors. Okay. Do not include 1. Okay. And we usually include right with exponents when appropriate. And the prime factors are usually listed from least to greatest. So we can use factor trees as a system for finding the prime factorization, or we can use something called division ladders. So let me show you how both of these work. So let's take, first of all, let's go ahead and let's take the number 60. Okay, so in both these systems, I'm going to start with the value of 60. With factor trees, I'm going to say what two numbers can multiply to give me 60. It doesn't matter which ones I start with. So for example, 6 times 10 is going to give me 60. Are either of these prime? No. So what two numbers can multiply to give me 6? Well, 2 times 3 gives me 6. And these are both prime numbers, so I'm going to circle them. For 10 is going to be 2 times 5. Once again, both these are prime numbers. If they weren't prime, then I would continue kind of with this break off of the factor tree. So because all 4 of these numbers are prime, I'm not left with any numbers that are not prime. I can say that 60 is going to equal 2 times 3 times 2 times 5. But I'm going to choose to reorder this. I'm going to say that it's going to be 2 times 2 times 3 times 5. I'm going to write it with my smaller factors to my left, and then kind of so the factors are increasing. So it's 2 times 2 times 3 times 5. In addition, I'm going to choose to write this as 2 squared because I've got the 2 times the 2 times 3 times 5. So just to try and kind of condense it. So this would be what's called the prime factorization. Okay. For division ladders, I'm going to kind of take the same idea, but kind of using my rules for divisibility, I'm going to think, what is 60 divided by? Particularly, what are the prime numbers that go into 60? So using prime numbers only, 3 goes into 60 20 times. Okay, what's a prime factor that divides into 20? Well, 2 is. So 2 goes into 20 10 times. Prime factor, it's divisible by 5, which leaves 2. So, in a sense, my prime factorization is going to be given by these outside numbers, which then I'm going to reorder and say it's going to be 2 times 2 times 3 times 5, or once again 60 will equal 2 squared times 3 times 5. So these are two different methods basically to get to the same answer. So hopefully this will be a good review of what we covered in class, and will be enough for you to start on some problems for homework as well as in class tomorrow.